As you can hear from my slight accent, I'm not from the Northwest. But I came to United States first time when I was a student, and typically from Europe, you land in New York, you rent a car, unlimited mileage, and you just drive for 6 weeks. So that's what we young Europeans do, and when I reached the Northwest, I decided that's where I will live. So I applied to 2 schools, Oregon State University and UBC. And in the end, I chose UBC because there were these famous professors at the time, Borg Matz and Ricardo Foschi, and I knew that I would study timber. So that's what I did. I came to the Northwest to study timber. And after that, I was extremely lucky. I got connected straight into the top people in the wood industry, started going back and forth to Europe, and started bringing the technologies, working close with Structuram, our local supplier. And then we brought the level of technologies in BC pretty much to the same level as they have now in Europe. And what I would like to share with you is that how we did it in BC, where we are, and where we think we're going next. So we just had TED Talks in Vancouver a month ago, and I wanted to say that I wanted to be like these TED Talk guys, you know, that run around the stage and they're so cool and they're so entertaining. But you know, when I saw how you guys present here, like you're stars, you're just like the same as all these people. So one of the TED Talks that I've seen from this year was by Al Gore. So Al Gore was giving an update on the environmental message. He was talking, you know, that first, 12 years ago, he started these talks, and now what's happening now? So what's happening now is that he had lots of hope in his message. He was saying that these new technologies of wind and energy and green energies are really becoming mainstream. And he was explaining why. He was saying that when the cost of these energies goes down, this is the tipping point. This is where these technologies are getting huge investments, and this is where it all becomes reality, and then it's when it goes for mass market. So I wanted to talk about mass timber going for the mass market, and I wanted to explain it to you how this will happen and how it will become a reality. So in my mind, it will become a reality when the buildings that we build with mass timbers will become better, safer, and cheaper. And after doing a whole bunch of iconic buildings like this AGO, Art Gallery of Ontario, and numerous others, we already gained enough experience to be positive how to make it happen, how to go and change this system that we have with mass timber. And from the structural point of view, what I want to tell you now that with the introduction of CLT, with the introduction of solid wood panels, we have a full system. Before we just had post and beam, before we couldn't really compete with concrete. Now we can. Buildings like this one, Earth Science building at UBC, they could have been done exactly the same way as thin timber, but they are done in mass timber using CLT and glulam. With this combination, we do have a system that can do it. So why would you change it? Why would you change the way we build into this? You only change it if it's better and safer and cheaper. So let's start one by one. First of all, for me, the most important thing why mass timber is the best thing here as a alternative is it's local. From BC, from Northwest, from Washington, from Oregon, we get the local material. But a lot of people don't care about it. They care about the quality of their buildings. So they care about the acoustics. We know that buildings like, we did the Earth Science building, part of it is in concrete, part of it is in steel. And when the people walk from one part of the building to another, when they start walking from the concrete to wood, they do not see the difference. This is the biggest thing for us, that we can now make the floors that feel exactly the same way in mass wood as they feel in concrete. The same thing goes about acoustics. we can achieve such superior acoustics with these systems that was not possible before to do it with just traditional materials. And then it's energy. We can achieve passive house, we can achieve net zero, we can achieve all these great energy efficiencies so much easier with building with CLT and with building with mass timber. The other thing is that we can make the buildings safer. And what does it mean for a structural engineer to make the building safer? It's the resiliency. Resiliency is what we as structural engineers want the building to fully withstand the forces of earthquake, hurricanes, floods. We want these buildings to be fully occupational right after the event. So this building on the slide here, this is an office building, 5-story office building in Taiwan. And some of you engineers that know Taiwan, you know that this is the highest seismic zone in the world and also very high hurricane zone. So what happened last summer, they had a super hurricane. Don't know if you remember, midsummer, they had a super hurricane. So what do? I get a phone call in the middle of the night that your building is shaking. And the phone call is followed by the email with the video how the building is shaking. And yes, it was shaking. The whole city of Kaohsiung was shaking. It was 2.5 times higher wind loads than what we designed for, okay? But after the event, after the storm was over, there was nothing wrong with the building. It was ready for immediate occupancy. So with the help of my little assistant here, I want to show you the concept of resilience. Okay? This is the most flexible assistant I ever had in my life. So right now, with mass timber, what we can do, we can start these systems that are post-tensioned, and they always bounce back, okay? So no matter, this simulates an earthquake, that's how we structural engineers get excited, right? Like, okay? And so this is how the buildings done with these post-tension systems in mass timber can be ready for immediate occupancy. And it's already demonstrated. It's demonstrated in New Zealand. My good friend Andy Buchanan is already doing buildings like this, okay? And we all know what happened to Christchurch, right? They had an earthquake. Most of the buildings stood up. There were some that fell down. But did you know that 10,000 buildings had to be demolished? Do you know what it means for insurance companies? This is why insurance companies are interested in my little friend Rudolph now. This is big money. This is how we can change the way we build, and we can do it the easiest using mass timber. So 6 is the number that I would like you to remember. Concrete is 6 times heavier than CLT. And the way we design for seismic, we design for a lateral force that it's a certain percentage of the weight. So if your floor is similar in concrete as it is in CLT, and most of the time it is, and if your walls are the same time, so your dead load of your building is 1/6 of that. This is why Gavin yesterday was showing that he can add all these flats on the building. But in the Northwest, what we really get excited is that our seismic force, it's so much lower. And this is huge. And this is how we will be putting more of these buildings up here. But the biggest thing is cheaper. The biggest thing is the cost. What we always hear from the developers that come more and more to our offices that, okay, we have this building, how much would this be in CLT? And you must be hearing exactly the same stories, right? So when we have this, we already tell them it's too late. You cannot design a building where it's already designed in one material and just do exactly the same in CLT. We can really help as designers, as architects and engineers. We can make the buildings so they are done exactly for CLT, for mass timber. And there are a few tricks that you can do, a few basic rules. And one of these rules is that you want to use as many panels that are exactly how they are fabricated, in the building. The cost goes dramatically down if you actually do this. The other thing, you want to use as many big panels as possible to lower the whole time of construction and lower the number of lifts on a building. It makes a huge difference for the overall cost. So how do we do it? I will look at few types of buildings, and I will talk first about the houses. Now, we have a great system here in the Pacific Northwest, which is called wood framing. And houses are done this way, and we should keep doing it like this. It's just absolutely wonderful to have this system, and we will continue doing it. Then there are high-rises. We work with Michael Green. We get all excited. You know, there is this race to the world, you know, like in Vancouver now 14 stories, in Bergen 13. We're now involved in the one that will be 20, and you know, the race will keep going on. But this is not where the majority of the lumber will be used for. The majority will be used in mid-rise. In mid-rise, in our growing cities, when there is a densification going on, and there will be a lot of buildings done between this 6 and 12 stories. And there was actually a great marketing story done in the United States that found out that the sweet spot for mass timber is 6 to 8 stories. This is where mass timber can provide cheaper solutions than concrete. We should all remember that. And this is exactly how this will start. And that's a little example from Vancouver, what we're designing right now. This is a building called TOMO. TOMO stands from Together More. And when I came to the first meeting, I was afraid of a group hug. And you know, as engineers, we're kind of more like, leave us alone and let us work on our software. Anyway, it turns out that it really requires working together on a building like this. And here, the private developer is making a building on a typical lot with no subsidies, in a mass timber, in passive house format, and prefabrication. And you would ask why, okay? To achieve passive house, and he's getting a special deal from the city, minimizing the number of parking lots because the city wants passive houses. To achieve passive house in typical 8-inch block for side walls, it's almost impossible. It costs so much money. But to achieve it with large prefabricated CLT panels, it's just the cheapest way. So prefab also will make it build much faster, okay? And the resiliency, the developer wants to keep this building. He wants to have an office, his own office on top of there. And he knows what happened to Christchurch. He knows that ultimately, maybe there will not be enough insurance for all the buildings that will fall down. He wants this building to be ready for immediate occupancy after. Sooner or later, something will happen in our region. So what you can do to make it happen. But before pointing a finger at you, you need always to put a finger at yourself. I live in a passive house. I live in a passive house that has CLT floors, and it has glue lamp post and beam, so it's a true mass timber. Yes, we made our own mistakes. I made mistakes with acoustics, but the passive house was done right, and it was the first registered passive house in the Northwest. So it is possible. And yes, I did pay 15% more for this, but all of you here and all of us who are in design and fabrication, we have a personal responsibility to start using these technologies for our own buildings. And this is how we should start. But as a public, whenever you buy a house, whatever, you should ask for quality. You should ask for better acoustics. You should ask for better thermal, better energy consumption. The developers will listen and they will change the way we build. So this is, if you're in an industry, start with the small steps. Just like in business, you start with incremental investments. Start with doing elevator shafts. Start with doing parts of the buildings in CLT. Then you will see that it can be cheaper, it's easier to incorporate the services, mechanical, electrical, and then you will win over. And as a government officials, you guys can actually do the most. You can help us change the codes, Just like in BC, we changed the codes to allow 6-story buildings, you need to do the same. We're now doing buildings both in Oregon and in Massachusetts, and we're actually trying to convince the governments there to change these limits. We also need to change the requirements for energy to make our buildings more energy efficient. My house has walls that are R47. All my neighbors think that I'm nuts. But the heating source, it's me and my wife, okay? When you have walls of R47 and R80 for the roof, you don't need much, okay? And the cost is not that much higher. So what we have to realize that here between Oregon, between Portland, Seattle, and Vancouver, we do have a cluster. Look how many speakers are from here. Look how much we already achieved. We have fabricators in Oregon, in British Columbia. We do have a center of excellence. Look at all these European companies. They don't come to New York. They come here. They come to Vancouver. They come to Oregon. They come to Portland and Seattle. We have a huge opportunity to make here, the Northwest, the center of the mass wood excellence and production. So I would like to finish with this. You know, how do we make sure that we succeed in this task of changing the way we build? And the way I think we do it, we change the requirements how we make it build. We ask for better acoustic. We ask for better vibration. We ask for better energy consumption of the buildings. We ask for the buildings to be resilient. And then when we ask for all of these things, the price will go down. And remember what Al Gore said. When the price goes down, the serious money will invest, there will be a large push, and this is how mass wood will reach the mass market. The buildings will become better, safer, and cheaper. Thank you.